Hello everyone, welcome to this video on Scatterplots. In this session, I am going to demonstrate simple scatterplots and also scatterplots with lots of conditions. Okay, so what is a scatterplot? Let's understand that first. Scatterplot shows the relationship between two variables. Let's take this data set. This is the data set that I'm going to be using. This is an insurance data set. Uh, Individuals pay a certain sum as insurance fee depending on their age, whether that individual is a smoker or not, body mass index, number of children, and sex. So these are the factors that influence the outcome. So charges is your Y, and all these are age, sex, BMI, children, smoker, and region are the X's. Okay, all these variables impact the outcome, which is Y. Okay, I can consider all the variables together, or I can consider each of the variables and how they relate to the outcome variable, which is charges. That is, I can consider what is the relationship between BMI and charges, sex and charges, age and charges, right? Region and charges, smoker and charges. That is known as, simple linear regression. When I consider all the factors together, it is known as multiple linear regression. Here we are looking at scatterplots. Scatterplots show the relationship between two variables. Okay, so there is no multiple concept here. It is only a case of each of the variables and how they relate to the outcome variable. So enough of concept. We will get into visualization now. So we are going to be using Seaborn. When I explain using graph, you will be able to understand this better. So let's import NumPy pandas, to get started. And if you see, I'm using Colab as the development environment. Okay. So the first step is we need to connect. The advantage with Colab is, it comes with the pre-installed libraries, and this is a cloud-based development environment. All of us are moving to a cloud-based development environment, right? Data is stored in cloud, and we code in cloud. Everything happens in cloud, right? So that is the advantage with a cloud-based development environment like Colab. Okay. So we have connected it, right? Always look for this green tick mark. Now let's come and run the codes. So the first one is, let's import NumPy and pandas. The next step helps us to establish the link between the place where we have stored the data set and the development environment. I have stored this data set in Google Drive. So I need to establish the connectivity between Google Drive and the development environment so that I can refer to this data set and start using it. So for this, I will run this set of codes. Okay, it will prompt you to connect to the email ID that you are using, and you need to give access, right? You need to give access for the Google Drive to share this information. Okay, let's allow this. Okay, let's give access, and now we have established the linkage between Colab development environment and Google Drive, right? So you will get this message. That means the running of the code has been successful. Now let's read this. Okay, that is the file that I just showed to you, the Excel file. It is actually a CSV file, comma separated value file, and after this we will import Seaborn because that is the library we are using. Okay, and we will also import matplotlib, right? So once we have run this, now let's start with a simple scatter plot. Okay, here I am studying the relationship between age and charges. Okay, and this data one is the data frame to which I have read the CSV file. Okay, now let's run this. Can you see? It shows the relationship between charges and age. Okay, a simple one. we are able to study the relationship between age and charges, right? As the age increases, the charges also increase. So there is a correlation, right? Now I can introduce additional variables into this. That is, I want to see this graph in different slices. Okay. For example, I want to see what is the relationship between age and charges for smokers, non-smokers, and for male and female, right? So in a single view, I want to see how the relationship really is there. Okay. So for that, let's run this command. See this here, x age, y charges, right? I need to mention data equals data1, right? Because the reference to the data frame is needed. Let's run this, okay? So what you see in hue and column, these are additional variables, right? For slicing the data or for slicing the graph. What you have here is all the data points pertaining to smoker, non-smoker, male, female, everything is considered here, right? So all I'm interested in this chart is how the relationship is there between age and charges. Okay, here I'm looking at the same, but I am looking at, is there a difference between smokers, non-smokers, and male and female, right? So I've introduced two additional variables. I think this is a very cool way of looking at scatter plots. Okay, now let's introduce some more conditions into the scatter plot. So for this, I'm going to look at the relationship between BMI versus charges, and I want to see how the relationship is there for age group less than 40 and age group greater than 40. Okay. So for this, I'm going to split the data frame into DF1 and DF2 corresponding to age less than 40 and age greater than 40. Once I've splitted the data frame, I'm going to be plotting separate scatter plots. Okay. And of course, I'm going to look at smokers versus non-smokers also in this. So the scatter plot studies the relationship between two variables, but I am introducing additional conditions in the form of smokers, in the form of different age groups. Okay, if I run the graph, I am able to see the relationship um, between charges and BMI for different age groups and for smokers versus non-smokers, right? So I am able to look at scatter plots by incorporating additional conditions. That is the beauty of these conditional charts, right? The line that you see here, this is known as the line of best fit. Okay, it shows the extent of relationship that is there between two variables. Okay, this is known as the line of best fit. In fact, we can use this to predict the future data points as well. Okay, and finally we will see a pair plot. Here we are looking at scatter plots between y and each of the x's in a single visual. That is, in a single visual, I'll be able to see different scatter plots so I can make necessary inferences, right? That is the beauty of this visual. So all you need to do is indicate the data, and you need to indicate, this is a case of regression, and show it. Okay, this is a very beautiful visual in my opinion, because we are able to get about 16 charts in a single view. See here, this is age versus age itself, which is why we are seeing a histogram and not a scatter plot. This is age versus BMI, age versus children, age versus charges. This is BMI versus age, this is BMI versus BMI itself, right? Then BMI versus children, BMI versus charges. Isn't this beautiful? You can use this as part of any analysis you are doing with your data set, because you need to understand your data set before you proceed with building machine learning models, right? So that is the biggest advantage with Parplot, right? So please note all these are scatter plots. Can you see the line of best fit? Right? These are all scatter plots. The advantage here is in a single visual, I get to see all the scatter plots, right? And I also get to see a histogram for each of the individual variables. Okay. And finally, let's see a heat map. Heat map is also a type of scatter plot because it shows the relationship between two variables, right? So let's run this code and we have a beautiful heat map. So what is the number in each of this square area? That is nothing but the R square value. R square tells the extent of correlation that is there. Okay. Let's take this one. This is charges versus age. It is about 30%, right? Not very high. If you have R square closer to 1, it means a strong relationship. Okay. If it is closer to 0, that means there is no relationship. Please note that R square can even be negative, right? A negative correlation and not a positive correlation. In these cases, you see a correlation value of 1, right? Because here we are comparing charges versus charges. That is the individual variable alone, right? There is no comparison. Because in this pair plot, we got histogram, right? All these histograms will correspond to a value of 1 here. So that's what I wanted to cover in this session. So we saw scatter plots, conditional scatter plots, and scatter plots and histogram in a single visual using pair plot, and we also saw heat map. Okay.